Hey SM2, so we're going to jump to 11.4 talking about volumes. So this is the first lesson of the very last unit. Okay, so we're talking about volumes of prisms and cylinders. Last off we talked about in 11.1 and 11.2 we talked about area, circumference. So we talked about circumference, arc length, area, and area of a sector. So now we're talking about volumes of prisms and cylinders. Okay. So let's go over some definitions first. Okay. So a polyhedron. So a polyhedron is a solid that is bounded by polygons. So a solid that is bounded by polygons. A polyhedron will have a face, and the faces are pretty much the sides of the polyhedron. Sides of a polyhedron. And they are polygons. Okay, an edge of a polyhedron is where two faces intersect. And a vertex is where three faces intersect. Okay, and you can see this right here in this photo right here. So here we have a polyhedron in this figure right here. This is a face. So this right here, this highlighted red area, this is a face, and faces have the shape of polygons. So this polygon in particular is a rectangle. So that is the face. And this right here is an edge. Right here is the edge where two polygons intersect. So you see that this trapezoidal polygon of this, so this face and this rectangle, they intersect and they create an edge. And then a vertex would be something like right here. It's a point where you see, so this polygon right there intersects with this face right here, this polygon, and it intersects with this polygon right here, that face. So you can see that's where three are coming together and it creates a vertex. Okay. So here are some types of solids right here. So here's a so on the left side you can see polyhedrons or polyhedra, which is the plural for polyhedron. So this is a polyhedron right here. Again, a polyhedra means that all the sides, a solid that is bounded by polygons. So every single side or face of the polyhedron has to be a polygon. So here in this first one you can see it's composed of rectangles. And here it's composed of a square as the base and then triangles as the sides, as the other faces. And then these are not polyhedra, these are more cylindrical shape. So you can see that it's a circle here, it's a circle here, this is a circle, so it's a sphere. So circles aren't polygons, so they are not polyhedra. So let's just take a look at some examples, see how we can classify polyhedra. So to name a prism or a pyramid, we use the shape of the base. Okay, so let's look at the shape of the base, and that can help us. Okay, so for A, you see that we have this solid, and first of all, is it a polyhedra or a polyhedron? Yes, it is, because you can see that every single face that it has, every single side is indeed a polygon. It is bounded by polygons. So it is a polyhedron. Now to classify it, let's look at the bases. So the bases of this polyhedron are right here. So you can see that they are rectangular, not quite square. So they're rectangular. So we call this a rectangular prism. So rectangular prism for this one right here. For B, you can see that we have right here, we have this hexagon as the base, and then we have the sides, which are triangles, which are polygons. So it is bounded by polygons, so this is a polyhedron. So that's a polyhedron. Okay, and then let's try and identify. So it is a pyramid of sorts. So that's the thing. So a pyramid looks something like this right here, and this one, sorry, not pyramid, a prism like this, and a pyramid is when it involves a triangular, when it involves triangles. Prism when it just involves something like that's more than three-sided, I believe. So for this one right here, it's triangular, so it's going to be a pyramid, but the base tells us the type of pyramid it is. So this is a hexagonal pyramid because it's a hexagon as the base. So hexagonal pyramid. And then as for this one right here, you can see that the base is a circle, which this makes a cone. Now, a circle is not a polygon, so this is not a polyhedron. So not a polyhedron. If we go down to these examples here, take a look at them, see what we get. So for the first one, is it a polyhedron? You can see that it is enclosed by polygons, so yes, it's a polyhedron. And it's going to be a pyramid, so we call it the type of pyramid by its base, so it's a square. So this would be a square pyramid. Okay, for number 2, this side right here is not a polygon. So this is not a polygon, so it's not a polygon, so therefore this shape is not a polyhedron. And as for this one right here, now you can see that the bases here are actually the bases here are the triangles, and then the other sides are composed of rectangles. So in this case, where the bases are the triangles, this is actually a triangular prism. So triangular prism. Okay, so the sides are composed of rectangles, but the bases are triangles. As contrast to this, where the sides are triangles, but the base is a polygon, like a rectangle or something more than three-sided. Okay, now let's talk about volume. So finding volume of these objects. So volume is, first of all, defined as volume of a solid. So volume of a solid is the number of cubic units contained in its interior. Okay, so cubic units. Now, let's think about units first. So, a unit that is one-dimensional, so like a line, is measured in something like inches or feet or centimeters, so on and so forth. But area, which is two-dimensional, is measured in inches squared, or feet squared, or centimeters squared. A cubic unit, which is three-dimensional, so a three-dimensional object, sorry, it might take a little bit longer to draw more sides to consider. Not even sure how good of a 3D object this is. Okay, so not very good. So this unit right here, this is a cubic unit in which it's going to be measured in inches cubed or feet cubed or centimeters cubed. Okay, so this is a cubic unit. So a solid is the volume of a solid is the number of cubic units contained in its interior. So right here we would take cubic units out of this right here. So a cube, like that. How many cubic units fit inside there? That's what a volume is. Now, I don't really know how to say this name right here, Cavalieri or something like that. This principle basically just in this illustration right here, what it says that, so it states that if two sides, or if two, not two sides, if two solids, so if two solids have the same height and same cross section, same cross sectional area at every level, then the two solids have the same volume. Okay, so here are these solids right here. So if you were to take a cross section of the solid, so here's a cross section right here. Now these two solids aren't quite exactly the same. You see that this one's slanted more, this one's upright. But the volumes will be the same if we take this cross section right here, and if at every single level of the cross section, at every single level, if the cross section area is the same, so right here where this purple area is, if it's the same at every level, then they have the same volume. So that's what this principle says, which makes sense. Okay, so to find the volume of a prism, volume of a prism is equal to the area of the base times the height. So the base times the height, where B is the area of the base. Okay, so you see B is the area of this base, and so the volume, you just have to take that base, and it's pretty much just like adding up every single level together inside the prism, and that's how you find the volume of said prism. Okay, so let's do some examples here. So find the volume of each prism. So if we're going to find the volume, we need to know the area of the base. So here we're given the height. We just need to find the area of the base. So the base here, you can see that the base is triangular right there. So can we find the area of this triangle? Area of a triangle is half of the base times the height. So this triangle has a base of 3 centimeters, and then we can say that the height is 4 centimeters. So the base is equal to half of 3 times by 4, which is going to be equal to 6 centimeters squared. So area is measured in squared units. Okay, and then to find the volume, we just need to take the base, which is 6 centimeters squared, and multiply that by the height, which in this case is 2 centimeters. And so when we do that, we get 12 centimeters cubed, because we have squared and centimeters right there. So multiply together, you get cubed. Okay. Alright, for this one right here, now the base is a trapezoid. Okay, so you get this trapezoid right here. Now the area for a trapezoid, if it was a while ago, but the area of a trapezoid is 1/2 of the height, I believe, right? 1/2 of the height times the bases. So 1/2 of the height times the sum of the bases. So base 1 plus base 2. Okay. Okay. I think I'm saying this right. Right. Thing is, okay, so we have this base right here, which is 14, and this base, which is 6. So if we do 1/2 of the height of the trapezoid, which I'm assuming they're saying is this right here. So 1/2 of the height. So that should be 3. The height should be 3. Okay, of the trapezoid. And then times by the sum of the bases, which is 14 plus 6. Okay, now that's equal to 1/2 of 3 times by 20. So together this should be 30 centimeters squared. So that is the area of this trapezoidal base. And then we need to multiply it by every single layer right there, which would be multiplying it by 5. So it's given this as 5. So we do the volume. So this was area. Volume would be equal to 30 times by 5, which is 150 centimeters cubed. Okay. Here are some that I think you guys should be able to do on your own. Okay, if you need help, so for number 4, number 4 is a I think that's 6-sided. So 1, 2, 3, 4, 5. No, it's a 5-sided. So it's a pentagon. You can easily just Google the area of a pentagon, and you can find it easily, no problem. But yeah, and then here the base would be a triangle, which we talked about before. Okay, so go ahead, try those out. If you want to try them out, you should try them out, but I can give you the answers just if you want to double check your work. So for number 3, you should get 11.25 centimeters cubed, and for 4, you should get 40 inches cubed. Okay. Oh, just kidding. So right here, it actually tells you the area of the base. Didn't really recognize that. So the area of the base right here is 10. So this area is 10 inches squared. Oh, okay. So we pretty much solved this one already. So that's the base, and then the height is 4. So 10 times 4 is 40. So sorry, I wasn't paying attention to all the dimensions that it gives you there. But anyways, try this one at least. Okay, find the area of the triangle and and then multiply by the height of the prism. Okay, now let's move on to talking about cylinders, the volume of cylinders, which is pretty much the same thing. The volume of a cylinder is still the area of the base times by the height, but in this case, B is the area of the base, and H is the height. So B is the area of the base, but the base is a circle, so the base should be pi r squared. And so pretty much the volume converts to pi r squared times by the height. So that's the volume of a cylinder. Okay. So it's still the same concept. We're still taking the area of the base and multiplying it by its height. Okay, so let's go ahead and try a couple of these examples right here. So find the volume of each cylinder. So the base has a radius of 9. So let's find the base. So base would be equal to pi times by 9 squared, which is going to be 81 pi. Alright, and then the volume would be 81 pi times by 6. Okay, so 81 pi times by 6. And I get 1,526.81. So my volume is equal to 1,526.81 feet cubed. For B, it's just because it's slanted doesn't really mean anything, because it's the same principle as we talked about before. I can't remember the guy's name. So the Cavalari's principle, because it's slanted doesn't really mean anything as if it wasn't slanted. It's still going to have the same volume. But in this case, so the base here is equal to pi times by r squared, which is 16 pi. And the area, or the volume, sorry, the volume would be 16 pi times by the height, which is 7. So 16 pi times by 7. And we get 351.86. And that's going to be in centimeters cubed. Okay. So go ahead and try these examples right here, 5 and 6. You could probably try 7 and 8. I can probably help you up, but it says, so the height of a cylinder, so if we have a cylinder, the height of the cylinder, so find the indicated measure. So we're looking for the height. So the height of the cylinder with a base with a radius of 8 inches, and a volume is equal to 2010. Okay, so if the volume is 2010, and we know that the height is 8, we want to find the height. So remember that volume of a cylinder is pi r squared times height. So volume of a cylinder is pi r squared times the height. So r is 8, so 8 squared times by the height. So in this case, that's what we're looking for. We're looking for the height. So in order to do this, we just need to divide by pi 8 squared on both sides. So height would be equal to 2010 divided by 64 pi. And that should give you the height. Okay. So that's how you can set that one up. And 8, you're looking for the area of the base of a pentagonal prism with a volume of 50 centimeters and a height of 7.5 centimeters. So you're looking for the area. And again, remember that volume is equal to the base times by the height. Now, base is area of the base. So that's what we're looking for. We're looking for the base. So we know that the volume is 50. is equal to the base, and the height of this is 7.5. Okay, so again, base here is the area of the base. So all we have to do is divide by 7.5 and we can find that base. Alright, to finish off, let's see if we can find some missing dimensions here. It's pretty much the same thing as what I just talked about. You're just trying to find a missing dimension. So we're given that the volume of this object, of this solid, is 661.5. And we know that volume of this has to be the area of the base times by the height. So the area of this base would be 18 times by y. So it would have to be 18 centimeters times by y, and then times by the height, which is 3.5. So we want to solve for the missing dimension y, so let's divide by 18 times by 3.5. So let's first do that. 18 times 3.5. And I get 63. So divide by 63, that's what will give us y, so 661.5. Divide that by 63 and you get 10.5. Okay, so y is equal to 10.5 centimeters. Okay, and then for 10, given that the volume is 75.36, and this is a cylinder, and we know the volume of a cylinder is pi r squared times by the height. So you can see that pi, the radius is p. So we have pi times by p squared times by the height of the cylinder, which would be 6. So we're solving for p squared. So we need to divide by 6 pi on both sides. So 75.36 divided by 6 pi. And we get pretty much like 4. So we get p squared is equal to 4, so then p has to be equal to about 2 inches. Okay. Alright, that should pretty much do it for 11.4.